Fellow citizens, pardon me. Allow me to ask, why am I called upon to speak here today? What have I or those I represent to do with your national independence? Are the equal freedom and of natural justice embodied in that Declaration of Independence extended to us? And am I therefore called upon to bring our humble offering to the national altar and to confess the benefits and express devout gratitude for the blessings resulting from your independence to us? Would to God, both for your sakes and ours, that an affirmative answer could be truthfully returned to these questions. But such is not the state of the case. I say with a sad sense of the disparity between us,
things about this course. This is a course for non-scientists. That portion of the enrollment policies is not a suggestion. I really don't want science majors in this class. If you are a science major, I'm going to notice, because that's one of the things that appears on the class list, what your major is. Don't take the course if you're a science major. Let me point out that, that freshmen don't have a major. So it doesn't matter if you intend to be a science major, if you're a freshman. If you are a science major, I recommend Astro 210, which is being given this term. I have a little handout on all the different introductory astronomy courses at the front of the room if you're interested.
I mentioned the book for the course, and the book is a book that I've written. It's not published yet, and so I'm going to put chapters from the book that are in fairly final form, and I think you'll find them easy to read, but you don't have to buy it. It's going to be posted on the internet, and I'll post chapters sort of in advance of the readings. And if you looked on the class's server, you saw Chapter 1, and Chapter 1 describes some of the sort of organization of biomedical engineering into subdisciplines, which I've listed here. And so we're going to talk about thinking about the body as a system that can be understood the same way a motor could be understood or a computer that could be understood.
Biological evolution has two big ideas. One of them has to do with how the process occurs, and that's called microevolution. It's evolution going on right now. Evolution is going on in your body right now. You've got about 10 to the 13th bacteria in each gram of your feces, and they have enough mutations in them to cover the entire bacterial genome. Every time you flush the toilet, you flush an entire new set of information on bacterial genomes down the toilet. Going on all the time. Now, the other major theme is macroevolution. This process of microevolution has created a history, and the history also constrains the process.
Welcome to class. Many of you will have recognized Frederick Douglass's speech, delivered in Rochester, New York, to abolitionist friends on July 5th, 1852. Douglass was invited by his friends to come to Rochester on July 4th to talk about the meaning of freedom, the meaning of liberty, the meaning of this great country. These were his friends. He refused to come on July 4th for the reasons that you've certainly heard in this excerpt. And this is a 3-hour-long speech I spared you 2 hours and 58 minutes of. It's a brilliant speech. But he refused to come on July 4th because to talk about independence and liberty to a person who emancipated himself was unkind at best, certainly blind.
All right. The particular topics that are under discussion, I've listed them here in green. The first of them are extrasolar planets, by which I mean planets around stars other than the sun. It's well known that there are many, many of these planets. All you have to do is watch Star Trek or something like that, and you'll find many, many examples. And this has been a staple of science fiction for quite a long time. Oddly enough, until 10 years ago, there was absolutely no evidence for this. We assumed that because the star is a normal star and there are many other stars, the sun is a normal star and there are many other stars like the sun, that there must be many planets of the same kind as the planets in our own solar system circling around all these other stars. But until 1995, there was not one bit of evidence to support that idea.
So at the end here of this first lecture, where I've gone some way in trying to tell you what biomedical engineering is about, I thought I would try to relate it in a different sort of way. And you've heard this poem, right? London Bridge is falling down. Everybody's heard this poem. You played the game. I don't know if there's video games now if people play games like this where London Bridge is falling down. But this is a picture of London Bridge. It's an interesting bridge which is important in the history of London. Bridges have really changed our society and allowed us to get from one place to another in ways that we couldn't have gotten to easily before.
So, where did this idea of evolution come from? Well, there are always ideas. You can go back to Aristotle and find elements of evolutionary thought in Aristotle. But really, it's a 19th century idea. And in order to see how it developed, let's go back to about 1790 or 1800. So at the end of the century of the Enlightenment. At that point, if you were to ask a well-educated person living in a Western culture how old the world is, they would say, oh, thousands of years. And if you were to ask them, well, where did all these species on the planet come from? They would say they were all created just the way they look now, and they've never changed.
I wanted to say something about morality and about mixed feelings that people have about finance. I note that undergraduate, I don't know how you feel about finance. Some people have a reaction. If you say you're taking a course in finance, they think that maybe you're selling out, maybe you value money too much, and that you should really be in some other field. That this is a long-standing conflict in our thinking. There is some contempt for finance, I believe, because it makes so much money for many people. Many of our students go into finance. Yale is very strong in providing people to the financial community. And I have to say they do very well.
"200 years later, after John Jack's attorney produces this epitaph, not quite 200 years, let's say 180 or so, Ralph Ellison, one of the great writers in the American past, identifies much of the same phenomenon that John Jack must have identified and that John Jack's attorney certainly understood. And he wrote this brilliant passage. I'll probably use it again later on in the course. Ellison wrote, "Southern whites cannot talk, walk, sing, conceive of laws or justice, think of sex, love, the family, or freedom without responding to the presence of Negroes." They're intertwined, linked fate, as it were.
The next topic is going to be black holes, and this is a similar situation. 15, 20 years ago, black holes were sort of poised precariously on the boundary between theoretical physics and science fiction, a boundary that is more porous than you might believe. But again, in the past 15 years or so, this has been converted into a standard topic in observational astronomy. There are dozens, probably hundreds of objects we can point to in the sky and say, yes, those things are black holes.
Okay, so for 150 years, organic chemists have chemistry courses have tended to acquire a daunting reputation. So you need help. I know you're very able, but trust me, you need help. So where do you need the help? The PowerPoints are available on the web. How many of you have already seen the PowerPoint for today, just so I have some idea? So about a quarter of you maybe. Okay, but anyhow, so your lecture notes are important, but you don't have to worry about getting everything down because you can download it from the web. And I do it on a Mac, but I try my best to make it compatible with PCs and even with the free PC viewer for PowerPoint. So you should be able to see it, but I don't see it on a PC.
So now I'm going to give you a brief overview of microevolution and macroevolution. Here's natural selection. Here's Darwin's idea. If in a population there is variation in reproductive success, what does that mean? Would everybody in the room raise their hand if they're an only child? Look around. There are about 5 or 6. How many of you come from families with 2 children? Lots. How many with 3? Quite a few. How many with 4? Quite a few, but not about as many as there were with only children. Anybody with 5? Yeah, a couple. Anybody with 6? No. If we were, by the way, in the 19th century, at this point, there would still be lots of hands going up.
I think in the remaining time, I will just go through an outline of the course, and that means go through the topics of the various lectures, and then I'll let you go for today. So the way this course is divided up is different than the financial theory course. If you look at John Akopoulos' course on financial theory, mathematical concepts are central to his outline of the course. But this being a financial markets course, I'm dividing it up more in terms of markets and institutions. But still, I want to start with some theory. And I thought that, I plan to start by talking about the most basic concepts of risk management, which underlie finance. And so that will be Wednesday's lecture.
This class is about post-emancipation, the post-emancipation African-American experience. It is about American history, and I hope that point is frankly very obvious, but one never quite understands or can anticipate all these things. It is about American history fundamentally. At its core, the course is about citizenship. Most important keyword for the entire class. The course is about citizenship. How one becomes a citizen, what one does to preserve that citizenship. At its core, then, the class asks the question, what does it mean to be American? Now, I will ask this question explicitly a few times in the class, but implicitly it is woven through so much of what I'm going to be talking about. What does it mean to be American?
Okay, so I should say something about course requirements here. Let's see. We have sections in this class. These sections are not just problem-solving sections. These are actually required. The fact that we're dealing in topics for which the answer isn't fully known means that one can actually have discussion sections, unlike many science courses, so we're going to do that. And so the structure of the course is like a history course, 2 lectures a week plus required section, and so 10% of your grade comes from sections. A large fraction of that is just showing up, but there'll also be something in terms of, saying something intelligent once you get there.
The last 2 centuries, both these most characteristic elements of Western civilization have in fact become increasingly under heavy attack. At different times, science and technology have been blamed for the destruction of human community and the alienation of people from nature and from one another, for intensifying the gulf between rich and poor, for threatening the very existence of humanity, either by producing weapons of total destruction or by destroying the environment. At the same time, the foundations of freedom have also come into question. Jefferson and his colleagues could confidently proclaim their political rights as being self-evident and the gift of a creator.
If we have strong selection, we can get pretty amazing things. I could illustrate adaptation a lot of different ways. I could do it, say, with the leaf-cutting ants that were the first farmers. They domesticated a fungus 50 million years ago and have been cultivating it ever since. That would be one way I could do it. I could do it with the exquisite morphology of the deep-sea glass sponges and how efficient they are at filtering stuff out of the water. I could do it with the design of a shark's body. Lots of stuff. I'll do it with bats, in part because when I was a Yale undergrad, I worked bats in this building. We had a guy that did research on bats at that time. Now, a lot of bats are insectivores, and they will hunt moths at night in complete darkness.
So anyway, the course I'm going to teach is called Financial Theory, and I'm going to teach an actual class. I'm going to spend the first half of the class talking about the course and why you might be interested in it, and then I'm going to start with the course. There are not that many lectures available in the semester, so I'm not going to waste this one. So the first half of the class is going to be about why to study it and the mechanics of the course, and the second half of the lecture is going to be actually the first part of the course. It'll give you maybe an idea of whether you'll find the course interesting too.
Near the Minuteman Park, there's also a cemetery. And at that cemetery, there's a headstone. My mother didn't take me on this field trip. We went with other people and did charcoal rubbings of headstones in Concord cemeteries. The story behind this headstone is where I want to start this course, really. It's a story about a man named John Jack. It's a story about an individual who certainly understood very well about a sense, the existence of forces much larger than himself determining his life. The epitaph reads, excuse me, God wills us free, man wills us slave. I will as God wills, God's will be done.
Newton writes down 3 laws of his own, but these are now 3 laws of motion, not planetary motion in particular. And again, one could write these down and memorize them and learn them, and that would be a good thing. Let me write down one of them. The second law looks like this. F equals ma, force equals mass times acceleration. And I write this one down simply to point out that that equation is the entire intellectual content of introductory physics for physics majors. If you go take Physics 180, this is all that they do.
Okay, so where are we going with this? What are the goals of our freshman organic chemistry? In fact, if you click that in your PowerPoint, you'll get taken to that site, but it's right on the website. You'll see it anyhow. First is to learn the crucial facts and vocabulary of organic chemistry. After all, that's what we think we're here for. And to develop a theoretical intuition about how bonding works. This is the goal for the primary goal of the first half of the fall semester, is to learn how bonding works really, right? And that relates then to molecular structure and also how bonding changes. And that, of course, is reactivity. But under the line, there are a lot of other things that we do in freshman organic chemistry that are arguably just as important, like make the scientific transition from school to university.
So, adaptation can be impressive. Drift is something that actually appeals to the geeks among us. I have a geeky side too, okay? Drift isn't such a morphologically or artistically beautiful thing. It's a mathematically beautiful thing. Drift happens whenever there is no correlation between reproductive success and variation in a trait. And it produces patterns like this. So here we start off with 20 populations, and we start them all with a gene frequency of 0.5. And we let meiosis, which is like flipping a fair coin, and we let variation and reproductive success take their course. And we just run these populations for 20 generations, and you can see that there's just about an equally likely distribution of end states out here.
So I took on, in my theoretical work, finance and economic theory on its own terms. I didn't think like Schiller to introduce psychology into economics. I just take it on its own terms, on its own mathematical terms. And what I found was that there are two things missing in the standard theory. One is that it implicitly assumes you can buy insurance for everything. It's the assumption that's called complete markets. And secondly, it leaves out collateral entirely. So you'll never see, almost in any single economics textbook, the idea of collateral or leverage. And those, I think, the idea that you can't get insurance for everything and that you need collateral, you have to be able to convince someone you're going to pay him back if you borrow money.
Now, this course is going to spend a fair amount of time examining this phenomenon, the linkage between freedom, not so much freedom and slavery, but citizenship and the denial of citizenship. And we're going to spend time investigating how this challenge, this problem, this tension, can be located in unexpected places. We will turn to primary sources of all types in order to examine this story. One place is a great example is just in currency. Stuff you're carrying, well, we don't carry much in terms of dollars and change anymore. It's on credit cards, I suppose, or debit cards. But back in the day, a few years ago, when we all carried cash, the story of a nation's myth is embodied on its currencies.
We've gone in about 40 minutes from the start of science to the theory of everything. So we're done. Everything else is a detail. And so the whole rest of the course is filling in details. The first of which, so let's start on the details. The first of which, I want to go back and catch one of Kepler's laws. And I want to write down the Newtonian modification of Kepler's third law. And that is an equation that looks like this. A cubed is equal to GMP squared over 4 pi squared. All right, we're going to circle this in red.
Okay, so modern science got underway in the 17th century. There's the 17th century, 1600 to 1700, right? And 1638 was when New Haven Colony was founded, and 1701 was when Yale was founded. So that's when everything got underway, just when this enterprise was beginning here. Okay, here we are. Okay? If you go back 100 years, you get to quantization by Planck, and we'll talk about that. And if you go back another 100 years, you get to Lavoisier and oxidation, and we'll talk about that. And if you get another 100 years, you get to Newton and gravitation, and we'll talk a little bit about that. And if you go back a little more than another 100 years, you get to Copernicus and the revolution of the heavenly bodies, and Columbus and navigation, and Luther and the Reformation. And these things all have something in common.
About macroevolution, the big scale process, the big picture. Well, here are sort of the basic statements about macroevolution. If anybody asked you, what does this fancy word macroevolution mean? Tell them, basically, this is it. There's one tree of life. Everything on the planet had a common origin. Everything is related to everything else, with the possible exception of the viruses, which are too small for us to decide. Their genomes are too small. The branch points in the tree were speciation events. That's when new species were formed. This history is marked by striking major events. There have been mass extinctions. There have been meteorite impacts. There have been major changes in the organization of the information structure of life.
So let me show you another picture. So this is a second way in which Shiller became famous. He said, well, look at housing prices, the Case-Shiller Housing Index. So he's also famous because he had the idea of collecting housing prices. So, you know, it's quite amazing. Every town has to record, you know, by law, you have to record in the town directory, and they're often on the internet, what the price is of every sale of every house. So everybody has it. It's all publicly available on the internet, or most of it is publicly available on the internet. And nobody thought to gather all this information together and take the average and write down an index, okay, until Shiller did it.
These are two examples of Confederate script. I wish I could make them bigger. They're actually JPEG screen captures. They really aren't, they pixelate pretty quickly. But you can see on these dollar bills stories that were important to the Confederate States of America. $1 bill and a $10 bill. And the stories you see that are important are here. Going back one image, I can use my mouse here, then down here. Oop. What you see is labor and white womanhood. And the labor you see is a slave. And I know it doesn't show up very clearly in this JPEG, but the labor is happy. The slave carrying the cotton is smiling. On the other bill, you have white womanhood.
This is a course, a version of which I've taught almost every year for the last 20 years, and it evolves a little bit every year. I think I get a little bit better at it, so hopefully you'll get some advantage from that experience. But the idea is to try to present to you sort of what's exciting about biomedical engineering, the ways that one can take science and mathematics and apply that to improve human health. And so I'm not working alone here, but we have 3 teaching fellows who are affiliated with the course, 2 of which are here today. Yen Ku is back there. Yen, raise your hand higher so everyone can see. Yen worked on the course last year, and so she's the senior of the teaching fellows that are working on the course this year.
Now here's how to succeed in Chem 125, and we'll take as our model science student Samuel Pepys. How many people have heard of Samuel Pepys? Have you heard of him as a scientist? What did you hear of him at? What do you associate with Samuel Pepys? Right in this period, right in the heart of the science growth. But what you know him for was his diary, which tells all about life, everyday life in Restoration London. He was actually as a 16-year-old present when Charles I was beheaded in 1649. Now, what's the connection? You know where this is? Has anybody been there? Dixwell, Gough, and Whaley Avenues. Those are named for 3 of the 50 judges that condemned Charles I to be beheaded. And they were the only ones that lasted very long.
So the key concepts from this lecture are that there are 2 kinds of explanation in biology. One is the proximate or mechanical question, which is answered by studying how molecules and larger structures work. Those are basically physical and chemical explanations. And then there are the evolutionary questions, which is why does the thing exist? Why did it get designed this way? And that can be answered either through selection or through history, or the best way to do it is to use both and combine those explanations. The thing that distinguishes biology from physics and chemistry is natural selection. This is not a principle that you can find in a physics textbook or in a chemistry textbook.
All right, so this is too hard for you to read, so let's do this. So let me just give you a few examples. Oops. Oh, uh-oh. I hope I didn't do a terrible thing. No. Okay, so let me just give you a few examples here of the kinds of, just so you think you realize there's something to the standard theory. There's a lot to it. So I'm going to give you 10 examples very quickly of the standard theory. So these are things that I'm guessing you'll have, at least some of them, trouble figuring out how to answer now, but by the end of the course, they should be totally obvious to you. So suppose you win the lottery, $40 million, or it's $100 million, the lottery.
We're going to look for stories like this in all manner of places. And through looking at these stories, we're going to see that the post-emancipation African American experience is several different types of histories. It's a history of political struggle, no doubt. An image here of black women voting, the 1950s, I believe. from the same night, and the history behind an image like that is filled with all kinds of political struggle that you certainly have at least a glimmer, a slim awareness of, glimmer of awareness of. But on the same night, in the same district, that struggle is embodied by this.
To answer the question, what is biomedical engineering, we're going to spend time on that today, and we'll spend time on Thursday. And I want to approach it from a couple of different angles. One is by just showing you a series of pictures which you might recognize and talk about why this is an example of biomedical engineering. And so this is one picture that probably you all know what it is when you see it. It's a familiar looking image. It's something that probably we all have some personal experience with, right? This is a chest X-ray that would be taken in your doctor's office, for example, or a radiologist's office. And it is a good example of biomedical engineering in that it takes a physical principle, that is, how do X-rays interact with the tissues of your body, and it uses that physics, that physical principle, to develop a picture of what's inside your body.
Now we come to the question that we'll address more. We have another 5 minutes here. The question we're really dealing with now, having seen how to work in Chem 125, is, are there atoms and molecules? How do you know, right? And what force holds them together? Because if we knew that they're real, and we knew what force held them together, then in principle we might be able to calculate everything, right? So it would all be theory. So is it springs that hold atoms together? So Robert Boyle, notice he's right at that time, 1627 to 1691, and he's the oldest person that's on the honor roll outside the building here. He's over that way. So Robert Boyle wrote this first important book in chemistry, New Experiments Physico-Mechanical, touching the spring of air.
This is Economics 252, Financial Markets. And I'm Bob Schiller. And let me begin by introducing the teaching fellows for this course. And so I have them up here. We have 5 teaching fellows at this time. And they're from all over. I'd like to put their pictures up so you'll know who they are. The teaching fellows are very international, and that reflects my intention to make this a course which is also very international, because finance is something about the whole world today, not just the United States. So we cover the world very well with our TAs. Usman Ali is from Pakistan, Lahore, and graduated from the LUMS, Lahore University of Management Science. He's a PhD candidate now in economics and is doing his doctoral dissertation on stock analysts' recommendations.
So the crisis of 2007, which we're going to spend a long time talking about, I just want to get back to that subject. Okay, so those list of questions were the kinds of things that I used to teach for years before I was confident about my theory of crises. And it's the kind of questions you have to face all the time at hedge funds, and decisions you have to make, and things you have to tell investors. And so that's the basic part of the course. But I want to say more, so I want to talk about the crisis of 2007, 2009. It started as a mortgage crisis. Okay, now how could it be that everything goes wrong in mortgages? I mean, they're 4,000 years old.
Moving to more local events in history, we can think now about the election of Barack Obama. 2 years ago, when I was teaching this class, Obama and Clinton were heading into the Democratic primaries, and I'll confess I thought Hillary Clinton had this thing locked up. And then this young senator from Illinois goes on a historic tear. And as I'm giving the lecture course, I'm like, wow, I've got to rewrite the end of my class. And then during that election campaign, there was the Reverend Wright scandal and Barack Obama's famous speech in Philadelphia during spring break, which I really had to rewrite the end of my class. After the class is over, he goes and gets elected.
Well, let's take a step back for a minute. That's sort of one way of looking at biomedical engineering, by looking at sort of the things that you know about that have been the result of the work of biomedical engineers, and talk more generally. So what is engineering? What do engineers do? What makes engineering different than other fields of study? What makes it unique so that we have a school of engineering at Yale that's separate from science and the humanities? Any thoughts? It's much more hands-on. I mean, you're actually in there doing things.
I'm going to ask you this question. Why are you here? That is to say, why should we, all of us, want to study these ancient Greeks? I think it's reasonable for people who are considering the study of a particular subject in a college course to ask why they should. What is it about the ancient Greeks between the years that I mentioned to you that deserves the attention of people in the 21st century? I think the answer is to be found, or at least one answer. The truth is there are many answers, and some of them is, it's just terribly interesting. But that's very much of a, what's the word I want? The opposite of objective. Subjective observation by me.
Let me start by talking about the textbook. So the principal textbook is Frank Fabozzi. The other authors are Modigliani, Jones, and Ferry. Foundations of Financial Markets and Institutions. This textbook is very detailed, and it may be I've had some reaction to students. It's more than I wanted to know, but I actually had a great experience reading it. It was an earlier edition. When I first assigned this book in the year 2000, I took it with me on vacation. I was going to the Bahamas with my family and with Jeremy Siegel's family. We'll come back to Jeremy Siegel in a minute. And I sat down by the pool with this book. Other people were reading novels and I don't know what, but I was reading Fabozzi.
Now, the prerequisites of the course, so I want to make this clear, you don't really need Econ 115. It will be helpful because this logic of the free market being good or bad, you know, that was already started in Econ 115. Oh, that's what they call it now, right? Still called 115, all right. So I used to teach it, but I haven't done it for years. So anyway, what you really need is mathematical self-confidence. It's not going to be high math, it's going to be simple math, but it's relentless over and over again. And I can tell you that every year there's the 5% of this, of you, let's say 5 or 10 out of the 100, 20 are going to just get bored doing problem after problem, and you're probably not that.
This is a screen capture from the Yale Daily the next day after Obama wins the election. There's a moment here of the student carrying one of the iconic images from the Obama campaign about hope and a suggestion of a new day. And again, the suggestion of a post-racial day. Now, I don't want to deny the fact this is an historic election for all manner of reasons, whether it was Hillary Clinton who won or Barack Obama who won. If a Democrat was to win, is going to be historic. I don't want to minimize that. But I also don't want to buy into the fact that simply because the nation has elected a president who is ostensibly black, and I say that very purposefully. We think about racial coding as we get later on in this course, you'll understand better why I say ostensibly black.
One of the other things that happened during the 20th century is that human life expectancy increased dramatically. People started living a lot longer. And so what I plot on this graph here is as a function of time, years, dates, life expectancy is a function of time. And what you'll see here is that about for the period before sort of 1700 or so, human life expectancy was less than 40 years of age. So that means a person that was born in that year could expect to live on average about 40 years. That was the expected lifespan. And the expected lifespans increased dramatically in the last couple of hundred years. Till now, for people that were born when you were born, you can expect to live to be 80 years old, a doubling in lifespan, fairly dramatic.
Now, the second great strand in the history of the West is the Judeo-Christian tradition, a very different tradition from the one I've just described. Christianity's main roots were in Judaism, a religion that worshipped a single, all-powerful deity who is sharply separated from human beings, makes great moral demands upon them, and judges them all, even kings and emperors. Christianity began as a persecuted religion that ultimately captured the Roman Empire only after centuries of hostility towards the empire, towards Rome, towards the secular state in general. And it never lost entirely its original character as an insurgent movement, independent of the state and hostile to it, making claims that challenged the secular authority.
Another thing that I will be talking about is less important to this course, but you heard of this? The subprime crisis. This is the big financial event which is hitting the United States and the entire world right now. I'm actually writing another book about this. It's not done in time for you to read, but I think I will have it done at some time during this semester. What does this mean? Subprime refers to the mortgages that were made mostly over the last 10 years or so to subprime borrowers. A subprime borrower is somebody who has a poor credit history or some other indication that would suggest that they might not be able to repay the mortgage. They might default.
So I want to end with one experiment. So, BA, can you help me with this? So this is something we're not going to have time to figure out the answer to, but okay. So I need 16 volunteers. How about the first two rows? Why don't you just volunteer? You'll survive, and I know it's a drag, but you'll do it. Okay. So what I'm going to do now is I'm going to run an auction. So please stand up, and 8 of you go to this side, and 8 come over here. That's okay. You'll be okay. I know everyone's reluctant to do this, so I only need 16. BA, help me count them. 2, 4, 6, 8. Okay, you guys have to come the other way. The TAs aren't going to participate.
So this is Game Theory, Economics 159. If you're here for art history, you're either in the wrong room or stay anyway. Maybe this is the right room, but this is Game Theory, okay? You should have 4 handouts. Everyone should have 4 handouts. There is a legal release form we'll talk about in a minute about the videoing. There is a syllabus, which is a preliminary syllabus. It's also online. And there are 2 games labeled Game 1 and Game 2. Can I get you all to look at Game 1 and start thinking about it? And while you're thinking about it, I'm hoping you can multitask a bit.